In this lab, the group members prepared a stock solution of aqueous copper 2 tetraamine, as seen in this calculation. Then they made a series of dilutions from the stock, as seen in this volumetric flask. To make the dilutions, we took a certain amount of the stock using a graduated pipette and read the bottom of the meniscus to get the initial volume, then the final volume after releasing some in the volumetric flask. We then filled the rest of the flask with water to the 25 milliliter line. We made the rest of the dilutions with the dilution before it. We calculated the concentrations using the formula as shown. Here is an example of how the student would read a volume from the graduated pipette. The graduations are 0.1, so there is a 0.01 uncertainty. In this example, the volume is 1.29 milliliters. Then we made 3 dilutions of an unknown copper solution, which we could later scan in the spectrometer to find the concentration of. For the unknown dilutions, we just used the same method, but just took a volume of the stock solution each time instead of from the previous dilutions. Each of these dilutions were placed into the cuvettes as shown, along with a blank cuvette filled with ammonia to zero out the spectrometer. It is important to make sure you transfer sufficient but not excess solution to the cuvette. It is important to scan across all wavelengths to find the lambda max, which gives you the wavelength of maximum absorbance to test all of your other solutions on. It could also be useful qualitatively with a reference graph to figure out what your solution might be if you don't know. After we scanned the stock to find the lambda max, we zeroed out the program using the blank cuvette, getting as close to zero absorbance as possible to subtract out absorbance due to other species in the solution. Then we measured the absorbance of each of the dilutions, recording them as we went, making sure to wipe them before putting them back in the spectrometer and closing it back.
In the arms of the angel.
Here are the values we got for each of the absorbances of the dilutions. Using the Beer-Lambert's law equation, we found the concentration of the unknown solution. As you can see, each of the letters represents a value or constant. We plugged in the average of the unknown absorbances to find the concentration. The relationship between absorbance and concentration should be directly proportional with an R2 value close to 1.